Okay, so in this video, we're going to use GeoGebra to create a Steiner network to connect the vertices of this triangle in a more efficient way. So if we look at this triangle right now, the minimum spanning tree would be the two shortest sides, which would be 3 plus 4, which gives us 7. So as of now, we have a minimum spanning tree weight of 7. So we want to create a Steiner point and connect these vertices through the Steiner point. Now you can do the Steiner point from any of the three sides. I always like to choose the shortest side because that takes up the least amount of space in my drawing space that I have available. So we're going to start by taking the circle tool, because the circle tool is much like using a compass, and we click on one endpoint, then the other, and this would simulate dragging the compass and putting this arc here. I will do this again, but this time I will start with the opposite endpoint and connect to show that I was drawing the arc from the opposite side. Where these two cross is going to be the location of my point that gives me the vertex for my equilateral triangle, and that is the first step in Torricelli's construction. So I'm going to take an intersection point, place it here, and now I don't need to see these objects anymore. And we'll come over to the line tool, choose segment, and this is my equilateral triangle. If you want to verify, you can click on the angle and choose distance and click on each side, and they all measure 3. Next, we would like to find the circumcenter of the equilateral triangle. We can do this by constructing perpendicular bisectors, and where they cross will be the circumcenter. So I come over to the second line tool and choose perpendicular bisector, click on the edge, then click on a second edge. Where those two edges cross, I will place an intersection point. Now that I have the intersection point, I will hide the perpendicular bisectors. I don't need to see them anymore. Now we will draw a circle centered at E that extends to B as its radius. And that circle should pass through all 3 of the vertices of the circle. We see that it does. It circumscribes the equilateral triangle. Next, we take the segment tool and we connect point D, which is opposite of AB, to point C, which is also opposite of AB. And where this segment crosses the circle, that is the location of our Steiner point. Put an intersection point there. And now I no longer need to see the circle. And I'm going to connect F, which is my Steiner point, to B, A, and C. I don't need to see this line anymore. Let's take a segment. Let's hit the graphics button, give it a different color. Let's make the line a little bit heavier so it stands out. And now I can click on my polygon and say don't show the object. I don't need to see these line segments anymore. I don't need to see these points anymore. This is my Steiner network. So let's compare the weight of my Steiner network to the minimum spanning tree. We'll come back to the measuring tool, click on each of these branches of the network, and we see we have 3.4, 2.4, and 1. If we add that all up together, we get 6.8, and we can see that the Steiner network weight equal to 6.8. So again, the Steiner network constructs the minimum network in our graphs as long as our triangular graph does not have an angle equal to or greater than 120 degrees. That is to say, if all angles are less than 120 degrees, build a Steiner network. If there is an angle 120 degrees or more, use the minimum spanning tree.